So following on from the previous video, we got to this stage here where we know one point on the plane. So we know one point on the plane, and then we would move 2 steps in the direction of the normal vector. So that would then take us to here. So we know the coordinates right here. The coordinates right here is given by this. So now we just need to set up a general point, x, y, and z. Now we need to demand that this vector here to be orthogonal to the normal vector. So in order to come up with the equation for our plane, we need to demand that this vector here to be orthogonal to this, meaning we need to demand that the dot product of this vector and this vector to be 0. That would then describe our plane. That would then describe our plane. That would then describe our plane. But the thing is, we are currently here. How do we get from here to here? What is the vector that would take us from here to here? Well, the vector that would take us from here to here is given by this. So it will be x take away this, and then y take away this, and then z take away this. So what this thing here represents is the path from here to here. So this thing here is our vector here, and then we demand that this vector to be orthogonal to our normal vector. So now make this demand. So now use a dot, compute the dot product. So it would be this times this, and then it would be this plus this times this. That would then give us this, plus this times this. That would then give you this. Now it's just a matter of tidying this up. So now multiply this out. That will then give you this, and then this times this times this. That will then give you this. Now times everything by 3. So that will then give you this, and then single number, throw them over to the other side, and then blah blah. That will then take us to this. So this is the equation for our plane. That is 2 units above the given plane, above our given plane here. So now we need to consider the one below it. So we've just come up with the equation for the plane that is above this one here. Now we need to come up with the equation for the one that's below. So now starting at a point at which we know this plane crosses, which is this bit here, move 2 steps down, 1, 2. That will then take us to here. So the coordinates here will be given by this. So now we demand that well, from here we know this point here. The coordinates at this point is given by this. So now we would set up a general point x, y, and z, and then demand that this vector here to be orthogonal to our normal vector. So this vector here is given by this, and our normal vector is given by this. We demand that this vector to be orthogonal to this vector. So that would then us making this demand here equal 0. So now it's just a matter of computing the dot product. It would be this times this plus this times this plus this times this, and then now it's just a matter of tying this up. So it's blah blah. That will then take you to here. So this is the equation for our second plane.